Yeah, student, welcome back to my session matrices. So in the previous lecture, we had taken a topic which was transpose of a matrix. So here I am taking a subtopic in transpose of a matrix, which is symmetric matrix and skew symmetric matrix. So for symmetric matrix, if one matrix is given and if we are taking transpose of the matrix, and the result we are getting same matrix, then we will say that the A is a symmetric matrix. You can see this matrix A I have taken. You take transpose of the given matrix, you will observe you will get same matrix. So we will say that the A transpose is A. So A is the example of symmetric matrix. For skew symmetric matrix, when we are taking transpose of matrix and we are getting negative of matrix, then we can say that the A is skew symmetric. This example is sufficient, I think. You take transpose of this matrix, so we are getting A transpose is equal to this matrix, and you take minus as a common, so you will get matrix A again, the given matrix. So here A transpose is minus of A, so therefore here A is a skew symmetric matrix. Now I'm going to take a very interesting theorem. This theorem says that every square matrix, be careful, I'm talking about a square matrix. So every square matrix can be uniquely expressed as the sum of a symmetric and skew symmetric matrix. It means if a matrix A is given us, so we can write the matrix in the sum of two matrices, and these two matrices, one matrix will be symmetric and second will be skew symmetric. So let's see how we will prove. So I'm assuming let A be a square matrix. So A can be written as half into 2A. Is it okay? Because multiplication and division by 2 we can do. This 2A can be written as A plus A. I have added A transpose and subtracted A transpose. Again, this equation is balanced. Now, this half A plus A transpose I have written here and half A minus A transpose here. So you assume this matrix is another matrix which is P, and this matrix as a Q matrix. So now we have to prove that this P is symmetric and Q is skew symmetric, because this square matrix can be uniquely written as the sum of a symmetric and skew symmetric matrix. So finally we have to prove that P is symmetric and Q is skew symmetric. So let's take P, which is half A plus A transpose. To prove that P is symmetric, we have to show that the P transpose is equal to P. So take transpose both sides. So we will take whole transpose, and this whole transpose means A plus A transpose whole transpose, because half is constant. So this is A transpose plus A transpose whole transpose. Why I am saying? Because one theorem you are knowing, A plus B whole transpose is equal to A transpose plus B transpose. So from here this is A transpose, and transpose is actually same matrix. One theorem is A transpose whole transpose is actually A. So this is the same matrix P. So we are getting P transpose is equal to P. So therefore P will be a symmetric matrix. Now I'm taking second matrix Q, which is half A minus A transpose. Again we have to prove this Q is skew symmetric. So take transpose both sides. So this is half A minus A transpose whole transpose. So this is half A minus A transpose whole transpose I have taken here. Now this is actually half A minus B transpose is equal to A transpose minus this matrix is B transpose. So A transpose is same, minus A transpose will be A. So now take a half minus common, so we will get half A minus A transpose. So which is minus half A minus A transpose, and it is matrix Q. So we are getting this Q transpose is equal to minus Q. So Q is skew symmetric. So finally we can say that this A can be written as P plus Q, where P is symmetric matrix and Q is skew symmetric matrix. Now take a easy question. If the matrix A is skew symmetric, we have to find the values of A and B. It is so simple. It is given that this matrix A is skew symmetric, so therefore A transpose must be equal to minus A. So what is A transpose? This is 0 A minus 3, so this will become column 0 A minus 3. Second row 2 0 minus 1 will become 2 0 minus 1, and this third row B1 0 will become B1 0. So this is A transpose. Write down minus, put the value of A here. Now next step, multiply by minus, so all will become negative. Minus A minus minus plus 3 plus 1. Similarly this minus minus, this plus 2 will become minus 2. Now both matrices are equal, so we will compare their corresponding elements. So finally we will get this A will be equal to minus 2 and B is equal to 3. Correct? Or if you are taking minus B is equal to minus 3, you will get again B is equal to 3. So final value we will get A is equal to minus 2, B is equal to 3. Now second problem, one matrix A is given and A is skew symmetric matrix. So you show that A and B are equal. So again it is so simple. If A is skew symmetric, A transpose will be A. So A transpose is 5A. So I have written 5A B 0 whole transpose. Again the value of A is here. What is the transpose of this matrix? It will become 5A column, B0 will become column, and both matrices are same, so their corresponding elements will be same. So A and B are same, so hence it is proved. Now take next problem. Here we have to express the given matrix as the sum of symmetric and a skew symmetric matrix. Now what is the procedure for that? Let's take, so this matrix A is given, then the transpose of A will be this matrix. Now we have to write this matrix A as the sum of a symmetric and a skew symmetric matrix. So from the previous theorem we are knowing that A can be written as half A plus A transpose plus half A minus A transpose, which is actually A is equal to P plus Q. So you find out P, which is half A plus A transpose. So write half, the value of A here, A transpose I have taken here. Add both matrices, you will get this matrix. Divide all the elements by 2, or we can say multiply all the elements by 1 by 2. So final matrix you will get 2, 2, 5 by 2, 2, minus 1, 3 by 2, 5 by 2, 3 by 2 and 2. So this is matrix P. Now when we are taking transpose of P, we will get this matrix because this row will become column. Second row will become second column, and similarly this third row will become third column. And again this matrix is matrix P. So now this P matrix is a symmetric matrix. Similarly we can write matrix Q, which is half A minus A transpose. So finally you will get this matrix after solving, and we will see this transpose of Q will gives minus Q. So finally we can say that this matrix A can be written as P plus Q. So this step we have to show, because we have shown right now is P is symmetric and Q is skew symmetric. So now we have to show that the sum of P and Q is equal to A. So write the value of P, write the value of Q, you add it, you will get this matrix, and this matrix is the matrix A. So hence it is proved. Let's take last problem. If matrix A and B are symmetric and they are of the same order, then show that AB transpose minus BA transpose is a skew symmetric matrix. So now do one thing. A and B are symmetric, so therefore A transpose will be A and B transpose will be B, because both are symmetric matrix. Now we have to prove this matrix is skew symmetric. So we have to prove that transpose of this matrix must be equal to negative of this matrix. So take this matrix and do one thing, take the transpose, because this AB transpose minus BA transpose is given. So take the transpose of this matrix. So what I am going to do, B transpose is equal to B. So in place of B transpose write B, and in place of A transpose write A. So this is AB minus BA whole transpose, and again this is A minus B whole transpose means A transpose minus B transpose theorem. And this AB transpose can be written as B transpose into A transpose. Again this is a theorem. And this BA transpose can be written as A transpose and B transpose, because reversal law. Now minus I have taken common, so it is A transpose B transpose minus B transpose A transpose. Again do one thing here, in place of A transpose again write A, because, and B transpose can be written as B. So finally we are getting the same matrix. So its transpose is negative of the same matrix. So therefore this matrix is a skew symmetric matrix. Now you do one thing, you solve more problems based on transpose of a matrix. Okay.